Namaste everyone, welcome to the class again. Now here in this lecture we are going to understand what is Venn diagram and we will see different operations on set. So Venn diagram. Venn diagram, it is nothing but it is a geometrical representation of sets. So suppose I have given a set, let us take universal set. Universal set, it contains element 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And let us define two sets, set A, which include 1, 2, 3, 4, 5. Okay. Let us define one more set B, which include 4, 5, 6, 7. And I want to represent these sets using Venn diagram. So in Venn diagram, we use a rectangular shape. Okay, this is our preferred shape. You can use any shape, but it is generally followed that with a rectangular shape we indicate a universal set. Now universal set contain element 1 to 10, in which element 1 to 5 are also present in set A. So set A will be represented inside this universal set. This is set A, and this set A will contain element 1, 2, 3, 4, 5. So 1, 2, 3, 4 and 5. Now there is one more set, set B, which contains 4, 5, 6, 7. So this 4, 5 is also present in B. So what I will do, I will take one set like this, in which 4, 5 and 6, 7 is there. So 1, 2, 3, 4, 5, they are the part of set A. 4, 5, 6, 7, they are the part of set B. They are also part of this universal set. Now in universal set, we have 1, 2, 3, 4, 5, 6, 7, and then we also have few more elements like 8, 9 and 10. So this is how we use these sets A, B and universal set using the Venn diagram. So the concept of Venn diagram is now, I hope, clear to you. It is a geometrical way of representing Venn diagram. It is always better to have geometrical representation, visible representation, because it is easy to understand from the graphs, from the diagram. Now let us discuss few operations on sets, and that will help us to understand the usefulness of these Venn diagrams. So operations on sets. The first operation that we discuss is union of two sets. Now union of two sets. Suppose I take an example of set A and B, then I will define union of set A and B as a set which contain all the elements present in A as well as in B. The elements which are common between A and B, we represent ones. Okay, so instead of using any other symbol for union of two sets, we use symbol as A union B. Now this U symbol, it stands for union of set A and B. So if I have set A which include few elements like 1, 2, 3, 4, and I have another set B which include elements like 3, 4, 5, 6, then I define union of set A and set B as a set. Okay, so instead of taking any other symbol, we use A union B, and this will be 1, 2, 3, 4, 5 and 6. So what we are doing in this set, we are writing all the elements which are present in A and which are present in B. The elements which are common, C, 3 and 4, these elements we are writing only once. So in set, as we discussed earlier also, that if there is repetition of member, then we write them once. So here also A union B includes 1, 2, 3, 4, 5 and 6. Second operation that we will discuss is intersection of two sets. Intersection of two sets. Okay, now before we discuss intersection, let us understand how using Venn diagram we show union of two sets. So we have set A and set B. So let us represent set A and set B. Now they cut each other because there is some element common. Now union means I want all the elements which are present in A as well as in B. So I will shade this whole area of A as well as B. So this whole part is nothing but it is A union B. Now let us understand intersection of two sets. Intersection of two sets is a set which include all the elements which are common to both set A and B. So if I have set A, again I can take the example of 1, 2, 3, 4 and 5, and I will take B as 4, 5, 6, 7. Then A intersection B. So this symbol, which is just the mirror image of U in Y plane is, or in X plane, is your intersection. A intersection B. So this symbol we use for intersection. Now A intersection B is a third set which include only the common element. So here the common elements are 4 and 5. So A intersection B includes 4 and 5. By using Venn diagram, if we want to show them using Venn diagram, so this is my universal set. This is our set A. This is our set B. Then intersection of A and B. So this part, which is common to both A and B, is intersection of A and B. Now let us discuss third operation, that is difference of two sets. Difference of two sets. So A minus B. A minus B, this is difference of A and B. Similarly, B minus A, difference of sets A and B, A minus B as well as B minus A, they are considered as difference of set A and B. Now they are not same, they are different. Let us see how. So if A include element like 1, 2, 3, 4, 5 and set B include 4, 5, 6, 7, then A minus B, difference of A and B, A minus B, is defined as a set which include elements of A, but does not include any element of B. So as you can see that 4, 5 is common between A and B. So while writing A minus B, we will not write this 4, 5. Okay, we will write only the element of A and we exclude any element of B if it is present in A. So this is A minus B. Now, as I defined A minus B, can you define B minus A? What is B minus A? B minus A, yes, you are correct that you will write all the element of B, okay, excluding the elements which are present in A. So 4, 5 we exclude and we show here 6 and 7. So if I want to show it on the Venn diagram, how it will be? This is our universal set. This is our set A. This is our set B. Now I want element of A, but I does not want any element of B. So you can see this part which is common to both. This we want to exclude. So we will shade only this much part. This part is your A minus B. Similarly, B minus A. So again, we take a universal set. This is our set A and this is our set B. Then in that case, B minus A is this part. This what I am showing is nothing but it is B minus A. So this is difference of A and B or difference of B and A. Now it is clear from this representation that A minus B may or may not be equal to B minus A. Okay. Now let us understand few properties of union and intersection of two sets. So I will come on the textbook. We have understood what is union, what is intersection. Now some properties of union. You can see that union of two sets A and B some properties of union of two sets. Now A union B is equals to B union A, commutative law. Commutative law, union of two sets, it follows commutative law. Commutative law means if I interchange the sets, then also their final result same. If I take union of A and B, it is same as union of B and A. Similarly, it follows associative law. Associative law, that if I take first union of A and B and then with the result I take union with C, the result will be same if I take union of B and C first and then its union with A. So A union B whole union C is same as A union B union C. So it satisfies associative law. Now union of A and a null set. So when you take union of A and null set, you will get your set A. This is called law of identity. Law of identity means union means you are taking all elements which are in A and in null set. So what you will get? You will get set A itself. If you take union of set A with A itself, then again you will get set A. This is called idempotent law. And finally, union of universal set and set A, it is a universal set. Now, intersection of two sets. Intersection of two sets we discussed. It is the common portion between set A and set B. Some properties of intersection also. First, it follows commutative law. It follows associative law. Now, intersection of a null set and set A is null set. You have seen that union of set A and null set is A, but here intersection of null set and set A will be null set. Similarly, intersection of universal set and set A is set A. So this is called law of null set or law of universal set. Now intersection of A and A is A. This is idempotent law. Union of A and A is also A. Intersection of A and A is also A. Distributive law. A intersection B union C is equals to A intersection B union A intersection C. This is your distributive law. Okay, so these are few properties of union of sets and intersection of sets. Now difference of two sets, as we discussed, difference of A and B, A minus B. So the difference of set A and B in this order is the set of element which belong to set A but not to B. Okay, so A minus B we have discussed, B minus A we have discussed. Okay, now we are in position to solve exercise 1.4. So let us move to exercise 1.4. Now here let us come again and see the problems from exercise. Now the first problem is find the union of each of the following pair of sets. X and Y is given. You have to find union of X and Y. So you will denote it as X union Y, and then you will write all the elements which are present in either set X or set Y or both. So 1, 2, 3 and 5. This is X union Y. The element which is common I have written once. Similarly, second we have to find union of A and B. So it will include A, B, C, E, I, O, U. Let us see this third example. Here we have A is a set of X where X is a natural number multiple of 3. So better first you indicate this with roster form 3, 6, 9, 12, ... B is X is a natural number less than 6. So B is a natural number less than 6. So it is 1, 2, 3, 4 and 5. Now we want union of A and B. So we define union of A and B, A union B, as in A we have 3, 6, 9, 12. In B we have 1, 2, 3, 4, 5. So A union B I will define 1, 2, 3, 4, 5, 6, 9, 12 and so on. Fourth problem, we have A is X, X is a natural number and X is greater than 1 and less than 6. So A is greater than 1 and less than 6. So in A, in fourth question, your A will be 2, 3, 4, 5 and 6. This is your set A. And your set B is a natural number greater than 6 and less than 10. So it will be 7, 8, 9. Now you can see that nothing is common now in set A and set B. So no problem. A union B I will define as A union B as set which include 2, 3, 4, 5, 6, 7, 8 and 9. This is A union B. Now A is 1, 2, 3 and B is null set. Fifth problem. A is 1, 2, 3 and B is null set. So A union B, now in this case A union B is set A only. So this is how we get union of two sets. Now let us move to next problem. A and B is given. Is set A is a subset of B? Yes, it is clear. So your answer will be, it is yes. A is subset of B. What is A union B? Also A union B is, we have set of A, B and C. If A and B are two sets such that A is a subset of B, then what is A union B? So when A is a subset of B, then A union B is set B. So here for this is answer for second question. For third question, we will say that A is, if A is a subset of B, then A union B is set B. Fourth question, set A include 1, 2, 3, 4, set B include 3, 4, 5, 6, set C include 5, 6, 7, 8 and D include 7, 8, 9, 10. We have to find A union B. Now A union B easily you can find, A union C you can find, B union C you can find, B union D you can find. A union B union C. Okay, now let us see this A union B union C. So A union B union C. So now you have to see all the three sets and you have to write all the elements present in A, B, C. So 1, 2, 3, 4, all the elements in set A. Then in set B we find that 3 and 4 are repeating. So I will not write that. I will write 5, 6 and in C I am seeing that this 5, 6 is repeating. So I will not write that and I will write 7, 8. This is A union B union C. Similarly, you can write A union B union D and B union C union D. Okay. So problems are very simple. Fifth problem is find the intersection of each pair of set of question 1 above. Okay. So in question number 5, we have to find the intersection. That means if I see this first question, I have to find A intersection B. Now A intersection B, you have to see the common element. So what is common element between A and B? So in A and B, we see that 3 and 4 is common. So I write 3 and 4. Then in the same way, we can find other intersections. Now this fifth problem, here we have to find A intersection B intersection C. So here I have to see an element which is common to both A, B and C. So 3, 4 is common here, but 3, 4 is not here. So if you see nothing is common, so you will say this is null set. This is the symbol of null set, or you will write like this. This is intersection of A, B and C. Now the next problem, sixth problem. Sixth problem we have A is 3, 5, 7, 9, 11, B is 7, 9, 11, 13, C is 11, 13, 15 and D is 15, 17. We have to find A intersection B. So again, simple, you can find all these things. Now let us see this question number 9 and question number 10. Question number 9, we have to find A intersection B union C. So first I will find what is A intersection B. So A intersection B, if you see, 7 is common, 9 is common, 11 is common. So 7, 9 and 11. Then we find B union C. Now B union C, we have 7, 9, 11, 13 and 15. Then we have A intersection B intersection B union C. So I have to find intersection between these two sets. So what is common? Element 7, 9 and 11 is common. So this is my A intersection B intersection B union C. In the similar manner you can find this 10th problem. 7th question is, if set A is a set of all natural number and B is a set of all even natural number and C is a set of all odd natural number and D is a set of prime number, then find A intersection B. A intersection B, A is a set of all number and B is a set of all even natural number. So what is common between A and B? A intersection B, you will find that it is set B only, because set B, it is a subset of set A. B is subset of A, therefore A intersection B is B. Next, you have to find A intersection C. Now A and C. So A intersection C, again it is set C. A intersection D. A intersection D, prime number is also a part of set A. So A intersection D is set D only. B intersection C. Now B is a set of even natural number, C is a set of odd natural number. So B intersection C, we have nothing common, so null set. B intersection D, it is even natural number and D is a prime number. So B intersection D. Now prime number and natural number, what is common? So 2 is common. There is 2, the only even number, which is prime number. And C intersection D. So we have to check the odd numbers which are prime number. So odd numbers which are prime number, there are many numbers. C intersection D. So here you have to check the odd number which is prime. So with 3 we can start. First odd number which is prime is 3, then 5, then 7, then 11, then 13 and so on. This is C intersection D. Okay. So operations on sets, they are simple. Which of the following pair of set are disjoint? Now I have to check disjoint. Disjoint, yes, I haven't discussed disjoint sets. Two sets, if no element is common between them, we say they are disjoint sets. So here we have two sets. In one set we have 1, 2, 3, 4, and in other set we have all x, where x is a natural number, which include 5, okay, greater than 4 and less than 6. Okay, so in the first problem, let us take A as 1, 2, 3, 4 and B is defined as, it is a set of x where x is a natural number and x is greater than or equal to 4. So 4 will include, 5 will include and 6 will include. Now we have to see the pair of disjoint set. Here if I take A intersection B, then A intersection B, I am getting 4 common. So therefore here A and B are not disjoint sets. Okay, so disjoint sets, there should not be any element common. In second also you can see that E is common, so it is not disjoint. In third, x is even integer and x is an odd integer, so here A intersection B, we can say it is a null set, and I will say that these two sets are disjoint sets. Now ninth problem is to find the difference A minus B. So A minus B, and ninth problem, what we see, that first problem, A minus B, elements are in front of you, A minus B. So you have to remove the elements which are common between A and B. So A minus B is also written as A minus A intersection B, which is common between A and B, that we have to remove. So here, okay, actually there is no need to write this formula, just you write the elements which are present in A but not in B. So 3 is there, 6 is there, 9 is there, then 12 I will not write, 12 is present in B, 15 is there, 18 is there, and 21 is there. So this is A minus B. I have written all the elements which are in A, but not in B. So any element which is also present in B, that I have to exclude. In the same manner, you can find other differences also. Let us take this last one, D minus C. So for D minus C, let us rub this. I am not solving all the problems, as each problem is similar to the other problem. So D minus C, I have to write the element of D, but I have to exclude which is also present in C. So I will write 5, then I will not write 10, then I will write 15, and then I will write 20. So D minus C is 5, 15, 20. Now next question, 10th problem. X is A, B, C, D and Y is F, B, D, G. We have to find X minus Y, Y minus X, X intersection Y. So X minus Y is equals to, now tell me what is X minus Y. I will write A, then B, B I will not write because B is present in Y. Then I will write C. That's it. Okay, because D is also present. So this is X minus Y. If you take Y minus X, then you will write F, then B you will not write, D you will not write, and you write G. Then X intersection Y. So X intersection Y is, what is common? B is common and D is common. So it is a set of B comma D. So this is intersection of X and Y. This is our 10th problem. Now 11th problem. If R is a set of real number and Q is a set of rational number, then what is R minus Q? If R is a set of real number and Q is a set of rational number. So if I remove all rational number, what is left? It is irrational number. So I will say that R minus Q is a set of irrational number. Yes. Okay. Okay, so that's it. We have solved all the problems of the exercise. Let us see. Is any other problem left? Okay, subset relation we have seen. 1.3 we have seen. Venn diagram 1.4. 11th and 12th question. Okay, two more questions are there. 11th question is, at the 10th and 11th we have done. 12th question is, state whether each of the following statement is true or false and justify your answer. 2, 3, 4, 5 and 3, 6 are disjoint. So this is false. 3 is common. A, E, I, O, U and A, B, C, D are disjoint. Now again this is false. 2, 6, 10, 14 and 3, 7, 11, 15 they are disjoint. Yes, this is true, nothing is common. And 2, 6, 10, 3, 7, 11 they are also disjoint, as nothing is common. Okay, so in this lecture we have understood what is a Venn diagram and we have seen some operations. We have seen some operations of sets. So we have seen union, we have seen intersection, and we have seen difference of two sets. In the next lecture, we will see complement of a set. Thank you for being with me in this lecture. I will see you in next class.